And once again, the astronomers discovered something nobody expected, and something that currently has no explanation. A peculiar hotspot visible in gamma rays that seems to produce an extremely high energy gamma rays in much larger quantities than from anywhere else, and that seems to be located behind our galaxy. In other words, it's a discovery of something extragalactic, something extremely powerful, and something that is going to help us answer another mystery we're going to be discussing in a few minutes. And so, hello info person, this is Anton. Let's discuss some of these new discoveries and specifically why this is important. But let's actually start with how this was found, because in this case, the process of discovery is also really interesting. And it actually starts with something entirely different. It starts with cosmic microwave background. You might already know what CMB is, but in case you don't, this is essentially the earliest light in the universe, something that appeared across the entire universe 380,000 years after the Big Bang. But this oldest light in the universe can only be seen in microwave frequencies, because after billions of years of traveling across the entire universe, it became so redshifted that it's now only visible if you have a microwave antenna. But it obviously began when the universe was extremely hot, and when some of the first atoms finally appeared. And even though we've known about this light since 1965, approximately a decade after, in the 70s, astronomers also realized that the CMB has a kind of a dipole structure. It's a little bit brighter on one side and a little bit darker on the other side. To be more specific, it's about 0.0035 Kelvin warmer or colder, which is roughly around 0.12%. And though at first it wasn't actually clear why this is so, it became pretty clear when the scientists started to analyze the motion of the solar system across the entire universe. And so not only is the solar system moving across the Milky Way at 230 km per second, even the Milky Way itself, along with several other galaxies, the galaxies we refer to as the local group, are moving toward a constellation of Centaurus at 600 km per second in this specific direction. This is the mysterious Great Attractor. You can learn more about this in one of the videos in the description, but in essence, because of this, the cosmic microwave background is a little bit shifted. Due to this motion, it appears a little bit hotter in one direction, a little bit colder in the other direction. And this is a result of blue shifting and red shifting effects due to the motion of the galaxy and the solar system compared to CMB radiation. And so a lot of the modern maps of the CMB generally take this into account and remove this dipole signal, making everything appear more or less equal. But in order to actually see if this is exactly what's going on, if it's basically because of the motion or for some other unknown reason, a lot of astronomers wanted to see if we can detect similar dipoles in other frequencies. And because a lot of these maps have improved so much in the last few years, it's definitely something that's achievable because there is enough data. And it just so happens that very recently we've discussed one of the biggest releases from Fermi Space Telescope, the Gamma Ray Observatory that you can learn more about in one of the videos in the description, that released over a decade of observations, even releasing this beautiful time-lapse you see right here. And it just so happens that this is the perfect amount of data in order to detect another potential dipole, but this time not in microwave frequencies, but instead in gamma rays. Because once again, if there is a dipole here as well because of the motion of the solar system and the galaxy, it will definitively confirm our predictions about the CMB, making the Great Attractor the main culprit. We obviously still have no idea exactly what it is, and that's because it's actually behind the galaxy, so it's very difficult to see what exactly this object could be. But no matter what it is, it seems to be located somewhere right here, once again in the constellation of Centaurus. But before the data analysis, the researchers here wanted to make a kind of an educated guess. Theoretically, what do we actually expect to see here, based on the expected velocities of the galaxy and the solar system toward the Great Attractor? But the observations reveal something different. Turns out that there is a dipole, but it's 10 times more powerful. As in, the actual emissions seem to be 10 times more powerful in this particular direction. Now, unfortunately, there's not enough data to determine if it's also 10 times lower in the opposite direction. As a matter of fact, right now it doesn't seem so. But what they did discover is that the gamma ray signal is extremely strong in the direction you see right here. And by itself, just the motion of the solar system and the galaxy does not explain these observations. Even though they did predict amplification of gamma rays in a similar direction as you see right here, the data from Fermi confirm that it's much more powerful. And even producing gamma rays with extremely powerful emissions of at least 3 billion electron volts. But in this case, because they removed a lot of extra sources of gamma rays, and especially much weaker gamma rays, and even removed the central plane of the Milky Way, they only got the results for the most powerful emissions only. So once again, it doesn't really tell us about the other side, or any additional sources from anywhere else. And here you actually see two circles. The wider circle shows us the location of whatever this is with approximately 95% chance. The smaller circle shows us the location with 68% chance. In other words, it shows us where these powerful gamma rays are very likely coming from. And though intriguingly, it does seem to kind of match the location of the great attractor at least a little bit, the peak of this gamma ray dipole is in a completely different direction from the dipole for the CMB, and obviously contains a much larger magnitude. And so in this case, they don't actually think it's because of the motion as much as something entirely different. Something related to another mystery that the scientists still don't know how to solve. You might want to check out one of the videos in the description about this, but in essence, it's the idea of these very powerful cosmic rays, what's known as the ultra high energy cosmic rays, with some so powerful that they currently have no explanation for how they acquired such energy. Now compared to gamma rays, cosmic rays are basically tiny particles, very often hydrogen or helium, but sometimes some kind of a different element such as even iron. And though for the most part, a lot of these cosmic rays have been traced to a lot of very powerful black holes, usually things like blazars, or basically supermassive black holes whose beam is pointed directly at us, the most powerful cosmic rays still have no explanation even today. They don't seem to come from locations where there is anything known to us. But turns out that most of them seem to come from this location as well. Both gamma rays and cosmic rays seem to contain a very similar dipole with very similar magnitudes, with a lot of them coming from this particular direction. And interestingly, at least for the cosmic rays, a lot less seem to come from the other direction, so there is a dipole after all. And though the actual number is not really that large, it's only about 7% more cosmic rays compared to average. When looking at the whole picture and when trying to pinpoint specific hotspots, this one really stands out. And at the moment, there is really no explanation for what's causing this. If it is a very powerful quasar or blazar or some kind of a supermassive black hole, so far nobody has found it. And though it could be because it's hiding behind all of the gas in our own galaxy, despite years and years of research and observing this in different frequencies, at the moment there's still no explanation for what this unusual source is. And since the location here is not so far from where we think the great attractor is, there is maybe a slight chance that some of these phenomena are somewhat related. For example, maybe because the great attractor attracts so many galaxies, many of them started to interact in this location and started to produce a lot more radiation and a lot more cosmic rays. Although technically when this happens, we generally see these galaxies from really far away. And because we're not seeing anything here, at the moment this is maybe not the best explanation. On the other hand, maybe all of this is a result of a really large structure that we're part of, and basically is a result of topology or us looking at all of this from a certain direction. So for example, maybe all of this is just a part of the cosmic web, and we're just looking at this from inside this tunnel-like structure with a lot of different matter and a lot of galaxies sort of aligned in the same direction, making it appear as if there's more radiation coming from this direction. Or maybe it's something entirely different. Honestly, at the moment, nobody knows. As a matter of fact, right now, it's all just guesswork. Since this was just discovered, and nothing else was found in other frequencies, currently nobody knows. The only link we have so far is the link of these cosmic rays to the slightly higher level of gamma rays. But we don't really know what all of this means. However, because of this link, we might be able to find the source of this once and for all in the next few years. It will probably require more observations from potentially other telescopes, but at some point I'm sure someone is going to link all of these phenomena into one and finally identify this unusual source. Either way, definitely a super exciting discovery, something we'll come back and talk more about in some of the future videos, but for now, we're going to add this to the list of mysteries still unsolved. You can learn more about other mysteries in some of the videos in the description, or you can also find out about one mystery that was recently solved by observing things in radio light. Here we're talking about odd radio circles. And so on that note, check out these videos and links in the description. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.